So the routing protocols in IPv6 goes very well. You have static route, RAPE, EIGRP, OSPF, ISIS, BGP, all supports IPv6. The link local address which always starts with FE80 will be used for neighbor discovery. Not only for adjacency, even for the routing protocols to discover neighbor, it's the same link local address. It is the same link local address that is going to be used by OSPF or BGP or any routing protocol. Whereas in IPv4, the public IP address, the layer 3 address is what we see that it is used by OSPF or EIGRP. When you type show IP EIGRP neighbor, you're going to see a layer 3 address as a neighbor. Whereas here, you will see a link local address which we are not using for communication. We use a separate address for communication. For neighbor discovery, it is link local address. The address that we use to communicate is not FE80. It should be something else like 2000 or 2001. We call it as global unicast address. Global unicast address. The address that begins with 2000, 2001, 2002, they're all called as global unicast address. So it's a unicast address. Even link local address is also a unicast address. The multicast addresses will all begin with FF02. FF02. For example, OSPF is 0 to : 5. And 6. If you have broadcast. And you know what should be for EIGRP RAPE? It's going to be FF02 : 9 for RIP and G. And then : 10, sorry, no 10 here, A, or IPv6 EIGRP. So this is what the address types that we have. But in the beginning, for a few years, like 2000 up to 2003, there was another range, another address called site local address. And this address is no more, removed from the standard. That used to start with FFC0 and FFE0. But this is no more. removed from the standard. This was for private use, but because we have enough of public IP address with IPv6 security, the industry has realized that there is no need for a site local address. There is no need for a private IP address. So we got only public, and that public is what called as global unicast address. It starts with 2000, 2001, 2002. The reason why it starts with 2000 is in the year of 2000, IPv6 have become standard. Not FFC0, FEC0, FEC0. This is no more. Okay. Okay, so link local address is also unicast address, global unicast address, multicast address. There is also one more, even currently we use, called anycast address. Any address can be defined as a anycast. This anycast address is to reach the closest device. Meaning anycast address is seen in many places, same address. Whichever is closest to your location will be responding. For example, have you finished multicasting? Have you finished multicasting?
I don't think so.
Okay, then I cannot take that example. We'll see multicasting as the next topic after this IPv6. Now, let us take simple another example, DNS. Let's say you got DNS server 1, DNS server 2. The reason why you have is anyone who is in this side, the left hand side, you want this to be the DNS server, and anyone in the right hand side should use this DNS server. It's the closest one. For A to reach DNS2 is cheaper than DNS1. For alpha, DNS1 is cheaper than DNS2. DNS1 is cheaper than DNS2 for alpha. How? For example, you are running OSPF. The cost on this link is 1, the cost on this link is 1, the cost on this link is 1. And this link is 1. All the link cost is 1. For alpha to reach this DNS is only 2. Whereas for alpha to reach this second DNS is 3. Which one is closest? DNS1 is closest. Whereas for a computer, reaching DNS2 is cheaper. Cost is only 2. So what they do is they provide the same IP address. Let's say DNS IP address 10.1.1.1. It's a private DNS. Locally you are maintaining one DNS. In this alpha also you give DNS address 10.1.1.1. In A also you have given 10.1.1.1, but A will be reaching this 10.1.1.1 because this is the closest. If in case this one goes down, the route will be removed from the routing table. As a result, this router will forward the packet here. So if one DNS goes down, the router will point towards another DNS because it's the same subnet, you see. Same subnet. Router will always show the closest one. If that closest goes down, it will show the next closest. So such type of address that you are going to duplicate should be defined as anycast address. Anycast means one to the closest.
So does it mean that you use the same address,
Yeah,
but at different places for the same purpose?
correct. Same address for the
Say,
same purpose.
like in our network we have like for a host VLAN, we have two gateway routers, and both of them have the SVI configured, but with the same address. So it's like I mean, it is like an Anycast gateway for the host. So my only question is, when some host, let's say, wants to talk to a gateway, whichever
Closest.
host, whichever is the closest, or whichever the packet goes first, is the one that responds.
Right.
But what happens to the, like, let's say there is a broadcast which goes to the gateway. The response would also be sent from the other gateway also.
No, actually,
Okay.
when A sends a broadcast, router has got a broadcast domain. It will route the packet only this direction. It will not send it to this direction. No way. Router controls the broadcast. This is not layer 2, no? This is layer 3.
Yeah. No, I'm saying like...
in your case, yes, it is layer 2.
Yeah.
Same VLAN.
Right.
Then both will be responding.
Right.
There, it is not a well suitable, that's not a well suitable scenario. Both the gateways will respond. That is not the way you should configure. For that, you have HSRP or VRRP to support. You can go with VRRP in such scenario. Your scenario is same VLAN, within same VLAN.
Okay.
This is not like that. This is different network in different, same network in different location. A router has got collision domain and broadcast domain on every single port. So that example will not match here.
Okay. I mean, our network, I mean, I haven't given you the full context. So our network is basically, it makes use of VXLAN EVPN.
Okay.
And we have, so let's say we have, on the top, we have the gateway routers.
Yeah.
Call them as border routers. Yeah, call them as border routers. And below them is the spine layer.
Yeah.
And then below spine is the access layer.
Yeah. What?
And then
no. Below leaf is the access layer.
Okay.
Spine has got Anycast RP. Multicasting is running. I'm talking about
no multicast.
I'm talking about the EVPN.
Right. Okay.
EVPN. Even though EVPN is BGP control plane, for bump traffic and non-unicast and multicast traffic, always the multicasting is used. For that, we will have an Anycast RP. That's why I asked, do we have multicasting? Have we covered multicasting? So there will be Anycast RP on the spine device.
We can probably discuss the designs in some other class, but it uses EVP and VXLAN, but it uses in a very different way than like a lot of the ways that is there on the internet.
Okay.
So we use centralized gateway. We don't use anycast gateway. Centralized gateway, but with anycast address. So we have only the border routers doing the gateway
Leaf.
function.
Leaf. That is what
Leaf,
called as
yeah, yeah,
pervasive gateway. Pervasive gateway. Floating gateway.
yeah, yes. And then there is this IP fabric from the access leaf to
So
the
there
spine to the
also,
border leaf.
there also, from the access layer, when a broadcast comes, the nearest leaf is what going to respond to you because it's a pervasive gateway. It is not centralized gateway, not at all. For the same IP address, every leaf will respond. That's what called as pervasive gateway.
Okay.
When the VNI matches, they are going to respond. For A computer, it may be leaf one. For B computer, it may be leaf two, responding to the same IP address but different MAC address because it is two different leaf.
Hmm.
That is why it is called as floating pervasive gateway.
Okay.
So it is not going to be from multiple leaves. It's only from one leaf. You will get a response when you send an ARP request to a gateway address. ARP reply may not be same for the members of leaf 1 and leaf 2, but the ARP request is same because the IP address is same. It's anycast IP. Whether we say IPs or anycast IPs. Very nice example.
Okay.
Fine. So these are all the address types that we have in IPv6. Next, what we are going to do is we are going to see how to enable some routing protocols in IPv6. Let's take on a small topology. Router 1 is configured already with ABCD colon 1 and loopback this one. Same like that, I have to configure R2 interface loopback 0 IPv6 address 2222 colon 2222 slash 128 interface G3 slash 0 IPv6 address ABCD colon 2 slash 64 interface F00 IPv6 address 2000 colon 2 slash 64. Show IPv6 interface brief. I do see an IPv6 address ABCD colon 2 and loopback as well as on F00 2000 colon 2. Let me try pinging R1. Sorry, R1. I'm encrypting. First, let me finish route 3. Okay, one more thing I want to tell you. On loopback interface, if you give second IP address, it won't override the first one. It will not override the first one. In IPv4, when you have an IP address and when you put another IP address, it will override. Say for example, here I have put an IP address 2000 colon colon 3. And I'm also going to put an IPv6 address 2222 colon colon 3 slash 64. Now if you go and check the interface F00, show IPv6 interface brief, you will have two IPv6 addresses on the same interface. Like this, you can have any number of IPv6 address on one single interface, which is not possible in IPv4. In IPv4, to achieve this, you need to create sub interface. In IPv6, you no need to configure sub interface. In IPv4, you have to. If you want to give different subnet on the same interface. Okay, I'm going to remove this. So you have to remove it. If you have done any mistake, you have to remove it. First you remove it and then you use the right one. Wow. Right? Okay. Now, if you check the routing table, show IPv6 route, you don't have the route to reach router 1 network and router 2's loopback network. You cannot ping now 1111 colon colon 1. We need a static route or a default route. On R3, I'm going to write a default route. This is how we write IPv6 route colon colon slash 0. Sorry, where should I send? 2000 colon colon 2. That's all. I have given the IP address of router 2 as a gateway. Likewise, I'll go and do it on R1 and check whether if it is already configured. I don't need to show IPv6 route. Okay, there is already a default route. Now on router 2, we need to write a precise route. Let's see how to write precise routes. IPv6 route, I'm saying 1111 colon colon slash 16. Meaning, if the 16 bit is matching, that is enough for me. Send it to ABCD colon colon 1, which is router 1's address. Likewise, IPv6 route, if you see 3333, just the 16 bit, the other bits can be anything, then you need to send it to 2000 colon colon 3. Now, if you try pinging, the ping will happen. Let us go and ping from R1. Ping 3333 colon colon 3333. The reason why it's not pinging is we have not joined the routed multicast group. So in R2, I have to say IPv6 unicast routing. Is this enough to ping? Yeah. Even though I have not enabled that command in router 1 and router 3, I should enable at least in router 2. Why? The router 2 is what actually forwarding the packet to left and right. The source and destination is neither, it's not R2. Source and destination is R1 and R3. So R1 and R3 is like a host here, sending request, sending reply. But who is there in the middle doing the routing job. Router 2. So router 2, at least you should enable this command. If not, the routing won't happen. The router 2 will not take the packet from R1 and give it to R3. It won't. Hope you understand the importance of this command. Any question? Any question? Any question? Sure, run section IPv6. This is what the static root. And we have to type this IPv6 unicast routing. If no question, we'll